Reimagine Time Day 21, page 51 in our notebook. This is Student Journal 50. We're going to write down some abbreviations for these things. The set of complex numbers is abbreviated by the letter C. With imaginary numbers, I still use the letter C because that's a complex number. And my personal viewpoint, I know why this is here, but I don't believe, I believe that real numbers, complex numbers contain a real number part. I do believe that, so I'll leave that there. But I just don't like that, and I apologize. I just don't like it, but that's okay. I don't have to like everything. Okay, so the set of complex numbers do have sometimes a real number part, and real numbers are represented by the letter R. Real numbers are broken into two categories: rational numbers, represented by the letter Q. Rational numbers are fractions, decimals, integers, whole numbers, and natural numbers. If you encounter a fraction or a decimal, it's just real and rational, R and Q. If you encounter an integer, then it's real, rational, and an integer, the letter Z. Remember, integers do not contain decimals or fractions. You're talking about the set of whole numbers and their opposites. So this is something the way integers would look. Then when you are looking at whole numbers, that's W. Whole numbers include the number 0. And then natural numbers, that's how you learn to count when you were in a preschool beforehand. And I need to learn how to count because I just put a 4 after a 3. 1, 2, 3, 4. So those are all the categories of real numbers. Rational numbers contain integers, whole numbers, natural numbers, fractions, and decimals. Irrational numbers. Pi is an irrational number. Definition of an irrational number is a non-terminating, non-repeating decimal. Pi never terminates and never repeats. And then we're talking about a radical that has a number underneath it that's not a perfect square. This is irrational. This is not irrational. The square root of 4 is 2, and 2 is a rational number. It's an integer, it's a whole number, and it's a natural number. So what we're going to do is we're going to look down here on them. Oh, I want to talk about complex numbers first. In the set of complex numbers, anytime you have a negative under a square root, or a radical under a square root, I should say, then you're going to have a complex number. The imaginary unit I comes from the square root of -1. So we're going to put the subsets for these numbers down here. I'm going to go through and take the square root of each one. The square root of 9 is 3. The square root of 0 is 0. Negative square root of 4 would be -2. The square root of 4 ninths is, the square root of 4 is 2. The square root of 3, square root of 9 is 3. The square root of 4 ninths can be written this way. The square root of 2 does not come out as a whole number, so I'll just leave it as that. And the square root of -1 is not a real answer. The reason is this negative under the radical. So right now, of all these, I can categorize this one the most simply. This is a complex number. That's it. Now, the rest of these are all real. So I'm going to go ahead and put a capital R because they're all real. Then let's decide which of these 5 are irrational. Which of these have a radical that did not come out as a whole number? And the only one that did not come out as a whole number is E. So that is real and irrational. You're done. You cannot put any other letters with this. Real and irrational, that's it. That's all the square root of 2 is. Now, we know that all of these, since I've narrowed this down, all of these are rational. So I can go ahead and put a Q with all of these because they are rational numbers. Then I need to look at each number individually. 3. It is rational. Is it an integer? Yes. 3 is a whole number. Is it a whole number? Yes. Is it a natural number? Is it a counting number? Yes. So it is all of them. And those are the answers to letter A. Letter B, 0. 0, of course, is a real number and a rational number. Is it an integer? Yes. Is it a whole number? Yes. Is it a natural number? Is it a counting number that you learned early on when you were learning to count? No, it is not. -2. Is -2 an integer? Yes, it's the opposite of +2, and that fits the definition of the set of whole numbers. So it is an integer. Is -2 a whole number? No, whole numbers cannot contain a negative sign, so it's not a whole number. Is -2 a natural number? No, you did not know what -2 was when you first learned to count. Okay, and let's go on to letter D. Is 2/3 an integer? No, it's not a whole number or the opposite of whole number. Is 2/3 a whole number? We just said it wasn't. Is 2/3 a natural number? No, it is not. 2/3 is just a fraction, and a fraction is just real and rational. Okay, let's move on. That was just categorizing numbers and realizing that these are complex numbers. Let's move on to Student Journal 52. This is still page 51 in our notebook. The imaginary unit I comes from the square root of -1. A complex number contains a real part and an imaginary part, a real part and an imaginary part. It's better written, I should have written it this way to start with. It's better written as A plus BI, where A is your real part and B is your imaginary part that's being multiplied by your I. An imaginary number comes from the square root of a negative. And a pure imaginary number would be a complex number without a real part. That's what a pure imaginary number is. Okay, quickly I want to look at these two concepts, these two core concepts. You're looking at the square root of -r. One step that I put in here, and I'd like for you to do it as well, is that you're going to break apart this negative from under the radical because that's not a real answer. So we're going to break that apart. The square root of -1 is I. The square root of r is just r. So when you look at this, in this example, I would expect to see this in between the answer and the original problem. The square root of -1 is I. I can't do anything with the square root of 3. So that is that answer. Is over here. I would expect to see this here. So that would be I squared. I times I is I squared. Square root of 3 times the square root of 3 is the square root of 9, which is just 3. In place of I squared, anytime we see that, we're going to put -1. -1 times 3 is 3. Okay, let's move on to Student Journal, page 53. The sum of complex numbers, the difference of complex numbers, and multiplying complex numbers. To find the sum of complex numbers, you add the real parts and add the complex parts, or the imaginary parts. To find the difference of complex numbers, you subtract the real parts and you subtract the imaginary parts. Be very careful with this. Subtraction of complex numbers is where students can often make a mistake. To multiply, you just multiply like we've done with polynomials. You're going to multiply 2 times this polynomial and -5i times this polynomial. 2 times 3 is 6. 2 times 2i is 4i. -5i times 3 is -15i. -5i times 2i is negative 10i squared. Combine like terms. 4i and negative 15i is negative 11i. And then I see an I squared, so in place of I squared, I'm going to put multiply by negative 1. 6 minus 11i. Negative 10 times negative 1 is positive 10. 6 plus 10 is 16. 16 minus 11i would be the simplified answer there. Okay, now I'm going to go on to Student Journal 54, and we're going to add and subtract. I think I'm going to ask you. Okay, so I went back and I found the sum and the difference for 9, 10, 11, and 12. I highlighted the common terms. I want to make sure to point out I didn't put an arrow here. Let's talk through the common terms. So negative 8 plus negative 1 is negative 9. 3 plus negative 2i is positive I. 36 minus 12 is 24. Negative 3i plus 24i, negative 3i minus 24i is negative 27i. Then 16 and negative 16, that would give me 0. 1i and negative 8i would give me negative 7i. Then negative 5 minus negative 6. Negative 5 minus negative 6. I know how you all love negatives. These make a positive. Negative 5 plus 6, that's positive 1. The negative 5i minus negative 6i is positive 1i. Now I'm going to multiply. I'm going to multiply this binomial times this binomial. And 9i times 15 minus I, positive 9i. Negative 15 plus I plus 144i minus 9i squared. Negative 15 plus 145i minus 9 times negative 1. So I'd have negative 15 plus 145i plus 9. Negative 15 plus 9 is negative 6 plus 145i. That's my answer to number 13. Now let's do number 14. I'm going to multiply 13 times 13 minus I and positive I times 13 times 13 is 169. 13 times negative I is negative 13i. Positive I times 13 is positive 13i. Positive I times negative I is negative I squared. Combine like terms. Negative 13i plus 13i is 0 minus negative 1. 169 plus 1, which is 170. Now I want to go back and do the second part of this. It says, then classify the result as a real number or imaginary number. And then if it's an imaginary number, tell if it's a pure imaginary number. Now when you look at any of these, can you pick out the one, there's only one, that is a real number? And that would be this one. 170 is my only real number. Okay, so the rest of them are imaginary numbers. Is there one that's a pure imaginary number? Remember I said earlier a pure imaginary number is a number in which you do not have a real part. Is there one of these that does not have a real part? Or more than one? Well, this one, you have a real part of negative 9. So this is just imaginary. This one, you have a real part of 24. So this one is just imaginary. Look, this one I only have an I. I have an imaginary part. So this one is a pure imaginary. And then for this one, it has a real part and an imaginary part. So this is an imaginary. And of course, all of these 9 through 13 are complex numbers. That's the best way, I think, to refer to these. Complex numbers, or a C.